First guest speaker for this afternoon. He's the Assistant Managing Director of Indirect Material Procurement, Pan International Thailand Company Limited, a subsidiary of ThaiBev. Please welcome Mr. Setha Thavisri. Sawasdee krab. And next, we are joined by the CEO of ECOCO or Fund Lead Change Company Limited, Taiwan, Mr. Andrew Lee from Taiwan. Next, we are joined by the Chief Strategy and Development Officer, Minus Global Holdings Inc., U.A.E., Mr. Samar Kamal. Mr. Samar Kamal, hello. Next, the Vice President of InEnTec Inc. U.S.A., Mr. Mike Rockett. Hello, Mr. Mike. From Italy, the Sales Manager and Engineering AMUT Group, Mr. Andrea Peretto. Hello, Mr. Andrea Peretto. Next, the Area Sales Manager for Asia, EREMA Plastic Recycling System Austria, Mr. Fritz Wimmer. Hello, sir. Thank you. Thank you, gentlemen. A very good afternoon to all of you from Bangkok, Thailand. We will run this session in English. However, Mr. Setha will run the session in Thai, and we have a simultaneous translation in our booth at the back here.
Oh, hi everyone. สวัสดีครับ
Sawasdee krab.
Okay. Allow me to speak in Thai a bit.
Yes. But before we begin, I would like to lay out the groundwork a little bit. Each of you will have 8 minutes in presenting your company, your ideas for the audience here. 8 minutes. So after 7 minutes is up, the last minute, I will shout out 1 minute left. Okay. So I will interrupt in between your speech. So you know that you have the last minute to wrap up and summarize, because we are pretty running.
I'll make the time
efficient. We gotta be time efficient.
แน่นอนครับเดี๋ยวจะพยายามพูดให้เร็วที่สุด
Time management
ครับผม
Okay, so we will start off by Mr. Setha.
ครับ
Okay.
ผมครับก็
If you're ready, please.
โอเค start นะครับก็จริงๆขอบคุณมากที่ได้ไทยเบฟมาพูดในงานนี้นะครับจริงๆเราต้องขอบอกตรงๆว่าไทยเบฟเนี่ยมีแนวทางในการทำงานเรื่องความยั่งยืนเนี่ยมาตลอดนะครับจริงๆแล้วเรามี2แกนด้วยกันนะครับแกนแรกคือการที่เรียกว่าน้อมนำนะครับตัวเศรษฐกิจพอเพียงของรัชกาลรัชกาลที่9นะครับมาเป็นแกนในการความคิดในการแนวทำนะครับไม่ว่าจะเป็นความเรียกว่าพอดีนะครับความมีเหตุผลแล้วก็รวมถึงความที่มีระบบคุ้มกันที่ดีนะครับอีกส่วนหนึ่งคือการนำหลักของตัว SDG นะครับ17ข้อเข้ามาจริงๆแล้วเพื่อผลักดันให้องค์กรเราเนี่ยสามารถที่จะเรียกว่าใช้เป็นตัวขับเคลื่อนที่จะให้องค์กรเราคำนึงถึงเรื่องว่าผู้มีส่วนเสียนะครับของในทั้งต่อสังคมแล้วก็ต่อทั้งสิ่งแวดล้อมนะครับในถัดไปจริงๆแล้วสิ่งที่เกิดขึ้นจริงๆแล้วถ้าในภาพที่ผมโชว์ข้างหลังนี่นะครับจริงๆแล้วในเรื่องของห่วงโซ่คุณค่านะครับจริงๆแล้วของไทยเบฟเราเนี่ยถ้า sustainability เราดูครบวงจรนะครับไม่ว่าตั้งแต่การทำ sourcing ทำ production distribution market and sale แล้วก็รวม post production นะครับจริงๆแล้วเรามีบริษัทหลายๆบริษัทที่เป็นบริษัทย่อยที่ดูแลพวกนี้โดยเฉพาะนะครับแต่วันนี้เนี่ยคงจะมีโชว์เคสให้ดูในเชิงของบริษัทที่ดูแลเฉพาะเลยคือเป็นบริษัทที่เรียกชื่อว่า ThaiBev Recycle นะครับซึ่งบริษัทนี้จะดูแลตั้งแต่ซื้อขวดแก้วมารวมถึงการจัดเก็บขวดพวกบรรจุภัณฑ์ต่างๆนะครับในเชิงของตัว waste management จริงๆแล้วที่เราทำทั้งหมดเนี่ยเราก็ยังใช้หลักการ 3R เหมือนทุกท่านหรือว่าที่องค์กรชั้นนำที่ทำนะครับ reduce reuse recycle นะครับแล้วถ้าเกิดมองถึง post consumption แล้วก็ในเชิงของ circular economy เนี่ยจริงๆแล้วเนี่ยเรามองไปไกลกว่าที่ทำ post consumption นะครับเรามีกระบวนการที่สามารถจะแยกสิ่งวัสดุที่เหลือใช้หรือว่าของเสียเนี่ยมาให้ทำให้เกิดประโยชน์ต่างๆรวมถึงแม้กระทั่งเอาพวกวัตถุดิบของเสียเนี่ยมาทำเป็น waste energy มากขึ้นเรื่อยๆนะครับทีนี้ในเชิงของตัววอลลุ่มที่เราใช้เนี่ยแต่ละปีนะครับเราก็จริงๆแล้วขออนุญาตไปหน้านะครับโอเคนะครับก็คือจริงถ้ามองจากมุมมองของ บรรจุภัณฑ์นะครับที่หลักๆที่เรานำมาใช้ในตลาดเนี่ยจริงๆถ้ามองภาพรวมเนี่ยอยู่ประมาณ 950,000 ตันเลยนะครับโดยแบ่งจริงๆแล้วขวดแก้วเนี่ยเป็นวัสดุหลักที่เราใช้ประมาณ 90% นะครับแล้วก็มีกล่องกระดาษที่เป็นบรรจุกล่องนะครับประมาณ50,000 ตันมีเพชรประมาณ 40,000 แล้วก็ประมาณอลูมิเนียมแคนกล่องกระป๋องนะฮะประมาณ 10,000 ตันเป็นต้นนะครับทีนี้ถามว่าแล้วไทยเบฟเราเนี่ยทำโค้ดลูปไหมจริงๆต้องเรียนว่าการทำโค้ดลูปของเราเนี่ยเป็นตั้งแต่เริ่มต้นของบริษัทเลยเพราะว่ามันมีการบริหารต้นทุนของการ reuse นะครับของขวดแก้วนะครับถ้ามองจากตรงที่เห็นจริงๆแล้วก็ต้องมีตั้งแต่สเต็ปตั้งแต่เราไปรับซื้อขวดแก้วมาจากที่โรงงานเลยนะครับสุดท้ายก็นำขวดแก้วออกมาอยู่ที่ฝ่ายการผลิตของเราแล้วสุดท้ายก็ส่งต่อไปให้ทาง retailer นะครับแล้วถึง consumer นะครับเสร็จแล้วเราก็จะมีอย่างที่เรารู้กันคือมีซาเล้งหรือว่ามีร้านค้าต่างๆเนี่ยรับเก็บกลับมาแล้วก็กลับมาให้ที่ไทยเบฟรีไซเคิลนะครับเป็นการรับซื้อเสร็จแล้วเราก็มีการคัดแยกนะครับของตัวขวดแก้วอันนี้เนี่ยถ้าขวดไหนที่ยังใช้ได้อยู่เรากลับไป reuse นะครับเป็น single use หรือว่าถ้าไม่ได้จริงๆเราก็จะเรียกว่าเอาออกมาแล้วก็ทำไปบดเป็นแก้วนะครับอันนี้เป็น challenge นะครับจริงๆแล้วไม่ได้ง่ายนะครับที่ทำตรงนั้นนะครับจริงๆแล้วสิ่งหนึ่งที่เรามองไปไกลกว่านั้นคือเรามองภาพว่าจะทำยังไงว่า2025เนี่ยเราสามารถจะเก็บได้ 100% จริงๆนะครับในเชิงของทำยังไงให้สามารถที่จะเอาวัตถุดิบที่เราส่งไปในขายแล้วกลับมาเนี่ยให้เต็มที่ไม่ว่าจะเป็นกล่องกระดาษหรือแก้วแล้วก็แน่นอนครับเพชรน่าจะเป็นในอารมณ์ประมาณที่ว่า2030นั่นนะครับเป็นต้นนะครับแล้วทำยังไงให้เราสามารถจะทำให้มีประสิทธิภาพมากขึ้นจริงๆแล้วคงเป็นอะไรที่ปฏิเสธไม่ได้ว่าปัจจุบันเนี่ยดิจิทัลโซลูชันเนี่ยเป็นสิ่งที่ทำให้เราเนี่ยสามารถที่จะมาใช้ประโยชน์ได้นะครับจริงๆแล้วเรามีโซลูชันที่เราทำอยู่มัน3เรื่องด้วยกันการทำ Big Data เรื่อง Data Analytics การเอา Robotic Technology มาใช้นะครับแล้วรวมถึงตัว AI นะครับในมุมมองของตัว Data Analytics จริงๆแล้วเรามีทำเรียกว่าโครงการเรื่อง Oasis นะครับจริงๆแล้วโครงการนี้คือทำอย่างไรคือว่าเรามีการเรียกว่าสามารถเอาข้อมูลมาช่วยวิเคราะห์นะครับในสิ่งที่จะเรียกว่าเรารู้ว่าข้อมูลของคนที่เราขายไปที่จุดไหนนะครับแล้วเรามาวิเคราะห์กับเรียกว่าซาเล้งหรือว่าร้านที่ขายเนี่ยอยู่ที่ไหนเพื่อจะช่วยประโยชน์ในการว่าสามารถให้เขาเนี่ยคืนว่าตัวขวดเนี่ยกลับมาให้ทันเวลานะครับแล้วก็สามารถจะใช้ประโยชน์เวลาเราเรียกของนะครับถัดไปที่เราทำอีกโปรเจกต์หนึ่งก็จะเรียกว่าเป็นโรบอติกในมุมมองของเราช่วยนะครับเพิ่มประสิทธิภาพให้กับแรงงานของเรานะครับในการเรียกว่ายกขวดลงออกจากที่แพลเลตหรือว่าใส่ในแพลเลตนะครับอันนี้ก็คือใช้ในเชิงของช่วยให้คนเราไม่ต้องเสียแรงในการที่จะใช้แรงงานที่ต้องหนักหน่วงนะครับแล้วก็จริงๆสุดท้ายอีกโปรเจกต์หนึ่งที่เราทำจริงๆแล้วเนี่ยก็เป็นสิ่งที่ดีมากคือการเอาปัญญาประดิษฐ์มาใช้นะครับจริงๆแล้วเป็นการช่วยกันคัดแยกนะครับก็ใช้หลักการคือ image recognition ก็หมายความว่าในเชิงที่ว่าเราสามารถที่จะให้เขาจำเรื่องขวดที่เรียกว่าขวดเสียหรือขวดไม่ดีเนี่ยคัดแยกให้เรานะครับเดี๋ยวผมมีวิดีโอให้ดูนะครับจริงๆโปรเจกต์นี้โปรเจกต์ที่เราร่วมกันทำงานกับทั้งไทยคือบริษัทเบฟเทคที่บริษัทภายในของเรานะครับรวมถึงบริษัทเรียกว่าโครงการที่เราร่วมกับมหาลัยที่ต่างประเทศ Carnegie Mellon นะครับรวมถึงตัวสถาบันเทคโนโลยีพระจอมเกล้าและกระบังนะครับช่วยกันทำโปรเจกต์นี้ขึ้นมาแล้วก็มีการทำในเชิงของเรียกว่าcross ในระหว่างนี้ก็คือเดี๋ยวนี้ครับเป็นสไลด์นะครับโอเคครับก็จริงๆแล้วก็มีการตั้งแต่เราทำการเรียกว่า machine learning data ต่างๆเข้ามาแล้วเราส่ง data เนี้ยไปให้ทางที่อเมริกานะครับได้รู้ว่าโอเคแล้วตัวรูปแบบต่างๆที่ต้องทำอัลกอริทึมหรือว่าโมเดลซอฟต์แวร์ยังไงเกิดขึ้นมานะครับแล้วก็รวมถึงสามารถทำไปแบบ scale ซึ่งธันวาจะเกิดขึ้นเร็วๆนี้ครับเราจะทำเป็นสู่ production แล้วครับผมมีวิดีโอนิดหนึ่งให้ดูนะครับเชิญเลยครับ ครับแล้วก็ในอนาคตอันใกล้นะครับเราก็มองภาพว่าการนำเทคโนโลยีเหล่านี้มาช่วยก็คือจะไปมองไกลมากกว่าขวดแก้วนะครับก็อาจจะมาใช้ประโยชน์ในเชิงของเอามาคัดแยกพลาสติกแล้วก็สามารถใช้เครื่องกลมาแยกให้เราได้รวมถึงกระป๋องอลูมิเนียมนะครับสุดท้ายที่ผมอยากจะฝากจริงๆแล้วเป็นความภาคภูมิใจของเราจริงๆในไทยเบฟเองและรวมถึงเมื่อเช้าที่ทางทีโอแต่ละท่านได้พูดจริงๆแล้วนะครับคือเมื่อเดือนตุลาที่ผ่านมาเนี่ยเรามีเรียกว่าปรากฏการณ์ครั้งใหม่นะครับคือว่าองค์กรชั้นนำที่เป็นต้นแบบของการพัฒนาความยั่งยืนเนี่ยมาจับมือกันนะครับแล้วก็มาคุยว่าเราทำยังไงเราสามารถจะขับเคลื่อนสิ่งเหล่านี้ให้ไปในอนาคตที่ดีขึ้นโดยมีธีมที่ว่าพอเพียงยั่งยืนและเพื่อโลกนะครับซึ่งจริงๆแล้วอีเวนต์เนี่ยนอกเหนือก่อนที่จะมาแชร์ไอเดียเรื่องความยั่งยืนแล้วเนี่ยจะเป็นการคุยเรื่องเทคโนโลยีโชว์เคสเหล่านั้นที่เราคุยเมื่อตอนต้นให้เห็นว่าสามารถที่จะมาแชร์อะไรกันได้บ้างนะครับจริงๆแล้วก็อีเวนต์นี้จะเกิดขึ้นทุกปีนะครับแล้วก็ขอเรียนเชิญแขกผู้มีเกียรติทุกท่านด้วยครับก็คงประมาณนี้ก่อนครับ
ขอบคุณครับ Time's up 8 minutes Thank you very much ขอบคุณคุณเศรษฐาด้วยนะฮะThank you. That's our first speaker. Next up, we have the CEO of ECOCO Fundly Change Company Limited, Taiwan, Mr. Andrew Lee. We get him back. Li 先生你好，你好。Can you hear me?
是。Oh, thank you, team. I can hear you.
Mr. Lee, if you're ready, I will start the clock. I'm sorry. If you're ready, I will start the clock when you say you're ready to go. Okay?
I'm ready. Oh, I'm ready.
You ready? Okay. 好，那8分钟开始哈。Please start. Go, Mr. Lee. Thank you.
Okay. Hello, I'm Andrew, founder of ECOCO.
ผู้ก่อตั้ง ECOCO
Hello. 看不见这个。I'm honored to join this symposium. Our company is very young.
บริษัทของเรายัง
We started about 3 years ago. Let me share you with our model. Let me share with you our model. ECOCO is a gamified system to make recycling fun and easy to use. The name ECOCO consists of eco and coin. We hope ECOCO is a system for sustainable resources. First, we started with recycling bottles. Every year in Taiwan, people use 4.5 billion bottles and 10 billion cans and 60 billion cans and 10 billion PP cups. PP cups is tea cups. Taiwanese is really crazy about bubble tea. We create a system called ECOCO to make recycling. Next. But let me share with you what we do next. ECOCO system uses circular economy model. When people put their bottle in the machine, and it will crush and store the bottles for you. Points in your app. On the app, you can choose the store you want to your points on. The points can be exchanged, discount, or coupons. We want to increase interaction with our user. That's our ECOCO model. Next. We have run our model in the market for several years. We have over 30 hubs in the market. This is our ECOCO app and points. Our platform has a scoreboard to show the point of all ECOCO users for the week. This creates a sense of competition with our user. In Teacher's Day, we following. Next. This is our spec to our machine. This is the spec to our machine. This machine is really attractive for people. Next. How does ECOCO work? We have an app you can download. When you go your number, then put the bottle in the machine. and you will tally your bottle on the screen. After using ECOCO, you get some point in your next. What we have accomplished. Next. Recycling 2.0. Next. ECOCO model helps streamline the recycling process by removing a few steps. Next. Environmental CSR. Next. We have over 35 participant vendors. These vendors absorb the cost of discount themselves as part of their CSR program. These vendors have been with us for several years. And all their acts to renew their contract because we bring customers to them and elevate their brand. Next. Marketing and gamification. Next. We had already hosted over 100 educational events for young children to teach them the right recycling concept and how to use ECOCO machine. We also made it into a fun video. Was well received and supported by their parents and schools. Next. One of our most popular events everyone can participate in is that who can put the most bottle in 1 million. This game is really exciting. On the right side, she's my first champion. We draw a comic for her. Next. We celebrate in festivals with our vendors by creating comics to interact with our users. Next. This year, we have a new milestone for a new machine to create a new machine to recycling batteries. Next, this is the first machine in Taiwan for recycling batteries. Before ECOCO, people had to have at least 500 grams of batteries to get a reward. By that time, the batteries may be rusted or leaked. So we create a new machine for recycling batteries, even just one battery. ECOCO's model tell people recycle battery, they need to recycle battery on time. Next. In Taiwan, people often go to recycle their battery in convenience store. ECOCO's model is 50 times more efficient than the traditional model. Next. Our model is really very easy and the output is really very useful. Next. Everyone in ECOCO's model wins. People can get some coupon on their spending. ECOCO can create a new platform and our partner can bring customer and we can make sustainable resources for environment. Everyone in ECOCO model wins. Thank you. This is my presentation.
Thank you, thank you. A big round of applause for Mr. Andrew Lee. 非常感谢李先生，谢谢谢谢。Thank you. From Taiwan, this is the CEO of ECOCO Fundly Change Company Limited, Taiwan. Okay, next up, we have our Chief Strategy and Development Officer, Minus Global Holdings, Inc., from the United Arab Emirates, Mr. Samer Kamal. We'll bring up Mr. Samer Kamal. Can you hear me, sir?
Hi, how are you? Yes, I can.
Okay. Mr. Kamal, a gentle reminder to you, you have 8 minutes to present, and then I will give you another reminder at the end towards the last minute. I will interrupt you with the word, you have 1 minute left. Okay, sir?
Okay. Yes, thank you.
Let me know when you're ready to go so we can start the clock.
Ready when you are.
Okay. All right. If you're ready, so 8 minutes for Mr. Samer Kamal starts now.
Hi, everybody. So Minus Global is a company that started a couple of years ago which is dedicated to tech-enabling waste management. Next slide, please. So the problem in the waste industry that we perceive is actually people like me. In 2007, I started a company in the U.A.E. that became the biggest waste management company in the Middle East. We raised $250 million. We had 450 waste vehicles. We were receiving 17,000 tons of waste per day, in our landfill. But we were only recycling a small fraction of the waste. In 2011, when I exited that business, I had a non-compete for 3 years. And during that non-compete, I had a lot of time to think about what the next steps in waste management might be for me. Next slide. And what I figured out was the next step for me was to take garbage trucks off the road. Next slide. The opportunity, the way we see it at Minus, is pretty straightforward. A lot of economic and environmental impact and a lot of contamination in the waste industry comes almost exclusively from the fact that we have so much transportation required in order to be able to manage waste through traditional infrastructure. And this economic impact comes from buying huge numbers of trucks, the purchase of the fuel, the impact on the roads, things like that. The environmental impact, I think, almost goes without saying. The idea that, you're burning fossil fuels in order to be able to transport material and the like. And then the idea that in order to be efficient in transportation, we often find that we contaminate what might have been clean waste streams, making them more difficult to extract resources from at a later point, becomes a big challenge in the industry. And so I want to talk to you a little bit about a case study. Next slide, please. And that case study for us was the first technology that we bought at Minus, which is a digester for difficult to recycle food waste in commercial kitchens. Next slide. That technology is called Orca. And what Orca essentially does is it takes the scraps from a commercial kitchen. I see we're one slide ahead. Takes the scraps from a commercial kitchen and applies microorganisms to those scraps and produces a liquid effluent that's very similar to sewage that goes down the sewage drain. Now, if you look at the infrastructure slide that's in front of you, the traditional model is food waste is generated and then it goes into a bin, and then that bin is collected by a truck, and then that truck is taken further along to perhaps a larger processing facility or a transfer station, and then from the transfer station it's put onto an even bigger truck, and then that bigger truck goes to a treatment point, which in most countries around the world is a landfill or a dump. By utilizing the existing infrastructure for sewage, and by thinking about that unrecyclable or hard to recycle food waste in a kitchen, we were able to dramatically reduce the environmental impact of transporting food waste, and able to send that organic material to a more efficient processing facility for organics, which is a sewage treatment plant. If you could go to the next slide, please. So what we're able to do then is we're able to separate out of the food waste some very important things: water, nutrients, and energy. We're able to do this because the microorganisms that are working on the food waste, they simply, by biomimicry, naturally I should say, the industrial process might be biomimicry, but naturally they separate out these three materials or make them easier to extract as we go further down the value chain. Next slide, please. And what we find is that there's a dramatic improvement in the impact on climate change using an Orca compared with traditional food waste solutions or alternatives, including anaerobic digestion and the like. Most of that improvement simply comes from the trucks. Transporting food waste in trucks makes very little sense for anybody, and it makes things very difficult in terms of resource recovery. And so if you can go to the last slide, please. Our tech-enabled company continues to look at new technologies that we can develop or acquire to take more and more garbage trucks off the road, with the goal one day in the distant future, but hopefully not too distant, that we can get away from garbage trucks altogether. That's my presentation.
Mr. Kamal, are you done?
Yes. Yes.
Sorry.
Thank
Okay. Thank you very much. A big round of applause for Mr. Kamal, please. The first man to actually start the largest waste management company in U.A.E. Am I correct? In Dubai? Yes, sir. Thank you very much.
Yes. Thank you.
Yes. Okay. Thank you, sir. Thank you, sir. Okay, next up we have the Vice President of InEnTec Inc. from the United States of America, Mr. Mike Rockett. He will have his 8 minutes. Good afternoon, sir. Can you hear me?
Yes, I can. Can you hear me?
Yes, sir. A gentle reminder, you have 8 minutes to present, and I will give you another reminder when you have your last minute. I will interrupt your presentation with the last minute warning. So whenever you're ready, please let us know.
I think I'm ready. Can you see my slides? Yes, I'm ready.
I'm sorry, your signal is not that clear. Can you repeat that, sir?
Is my slide up on your screen?
Okay, yeah,
your
slide is up now. So
okay.
Please, are you ready to start, sir?
Yes, I am.
Okay, so your 8 minutes starts now.
Thank you for having me. Our company is called InEnTec. We are based in Washington State in the United States. Our company was formed by scientists from Massachusetts Institute of Technology and Battelle National Labs in 1995, based on $300 million of R&D funding. And we have a proprietary plasma gasification technology that converts waste into renewable chemicals and energy that we're going to describe in detail. We have 55 patents. Here are some US patents, but we do have patents around the world. There's a lot of gasification technologies, and gasification as a concept has been around for a long time, but our patents provide us with proprietary technologies that make our system more efficient and operate with higher efficiencies, as well as to produce cleaner syngas. These are some awards and recognition that our company has received over the last decade or so, including from Wall Street Journal, Business Week, Platts. The most recent one was actually listed at the top there, Biofuels Digest, named one of our customers' projects that's going to use our technology as the #1 waste to value project in the world. And that's this headline over here entitled Carbon Rescuers, which focused on commercial feasibility in addition to sustainability. Our business focus, our technology is very robust, and so we are pursuing projects in a lot of different areas, including plastic circularity, distributed hydrogen, processing of high-value wastes, such as medical and hazardous, municipal solid waste to energy products, such as ethanol and methanol, and biomass to fuels as well. I'm going to describe our technology first with a general description of what is gasification. Gasification is essentially elemental recycling. The process of gasification cracks what we call feedstocks, which is all of those waste streams, into their atoms, and then reforms those atoms into simple molecules. And so I have an example here of what's post-consumer high-density polyethylene, or HDPE, plastic. On the left is post-consumer plastic chipped into about quarter-inch chips. This is plastic that was not recycled by traditional means. You can see here the formula is CH2 in long chains, and we recently had that mix analyzed, and you can see it's 85% carbon and 15% hydrogen. When you put that plastic into our gasifier, and this is actually an internal view of our gasifier, it cracks down into those atoms, which I'll describe more on the next slide. This is a little cartoon blow up of the core technology that's in our system. And as the president of PTTGC mentioned in his presentation a little bit earlier, the main part of the system operates at 10,000 degrees C, which is hotter than some layers of the sun. We create that using DC electrodes that spark an arc in what we call the plasma zone. And when they spark that arc, they create an ionizing environment. Anything we drop in there dissolves into its atoms. And then when those atoms come out of that cloud, they form simple molecules, so they don't really remember what they were when they started, and they form H2CO and CO2, which is our primary product. Anything that doesn't volatilize in that plasma arc zone drops into this molten glass bath at the bottom and comes out as a consolidated glass, like this picture here. First, talk about the glass. The glass itself is not leachable and it's not a hazardous waste. This is analytical on the right. The glass is very small volume compared to the original waste that goes into the gasifier. And at sufficient quantities, it can be used to make different kinds of products, including this is a blown glass cinder block, this is egret, and several other products. Syngas, however, is our primary product. This is an example mass balance of syngas produced from 1 metric ton of MSW as a feedstock. This is the composition of the MSW that went into our gasifier. After the syngas comes out of the gasifier, it goes through some syngas cleaning to remove any excess water or salts or any other volatile components that go through with the syngas. And we produce 890 kilograms of syngas from that ton of MSW. That syngas can be used to produce power. It can be used to produce pure hydrogen, or it can be used to produce liquid fuels. Syngas is one of the basic building blocks of the chemical and plastic production industries. So we can take in a wide range of feedstocks, and they can be mixed or heterogeneous as well, because again, the machine doesn't distinguish between them once it breaks them down into their atoms. And that clean syngas, which is our product, can be used to make ethanol, methanol, hydrogen, electricity. It can also be used as a chemical grade syngas input for chemical and plastic production. Our systems are modular and they're skid mounted. This happens to be a 125 ton per day system on the left. 3 of them together make a 400 to 450 ton per day facility. We also make smaller units, which I'll show some later. Obviously, there's a lot of waste in the world now and going up. Up in the left corner, only a portion is recycled. The rest is disposed. That's, of course, the topic of the whole symposium. To the extent it can be reduced, reused, and recycled is great. We also think of it as a resource for making new products at the elemental level. And the potential energy within the waste that's out there now is equivalent to approximately 5 billion barrels of oil if used to produce energy and chemical products.
You have 1 minute remaining.
Thank you. Here's some example facilities. This one's in Oregon. It makes hydrogen from mixed industrial and medical waste. It was built in 2010 and just recently restarted and expected to go into commercial operation next quarter. This was a demonstration facility used for PCB destruction in Japan. This was a smaller facility in Taiwan that processed medical waste and batteries. This facility in Michigan in the U.S. Processed hazardous waste. That hazardous waste had chlorine in it, so the chlorine went with the syngas and we used it to produce aqueous hydrochloric acid that we sold back to our customers. There's a mobile system. This system is a 450 ton per day system that I want to highlight because it has a very low or even negative carbon intensity when you look at a life cycle analysis based on the feedstock that it's using and the ethanol that it's producing at the back end. It's basically using a carbon that's already up here instead of bringing a new carbon up and using it one more time, but doing it in such a way that the greenhouse gas emissions are actually lower than currently, and so it actually has a negative carbon intensity. It reduces the amount of carbon in the environment by processing in this facility. And I think I hit my 8 minutes.
Yes.
Thank you very much.
8 minutes, sir. Thank you very much. Mr. Mike Rockett, the Vice President of InEnTec, Inc., United States of America. Thank you very much, sir. Very impressive. All right, next up, we have our sales manager and engineering of AMUT Group from Italy, Mr. Andrea Peretto. We'll bring up Mr. Peretto on our screen.
Yeah. Good afternoon to everybody. This is Mr. Andrea Peretto from AMUT Group, Italy. Yeah.
Mr. Peretto, can you hear me?
I can hear you very well.
Very well. Okay, sir. A gentle reminder, you have 8 minutes to present. And then I will give you another reminder when you have 1 minute remaining, sir. Okay?
Probably I will start with the presentation and I will cut out the presentation and ask the technical people to run a video. And the video will be much better explanation about AMUT technology. Okay, let's start.
Okay, so we have 8 minutes. Your time starts now.
Yeah. Okay, so AMUT is a group from Italy, is active in technology for recycle of plastic waste. Basically, we are talking about PET or HDPE, post-consumer bottles and film coming from flexible packaging. We are having also a division called AMUT ECOTech, taking care of the waste handling, like MRF, Material Recycle Facility, or PRF, Plastic Recycle Facility. In the same group, we are also taking care about activities like thermoforming, extrusion, and flexible packaging. Now, I would like the service, technical service, to start the video, because this video explain exactly what is doing AMUT technology to give a second life to the plastic waste. So if you can help me and start the video now.
Okay, sir. Video starting now.
Thank you.
Thank you, Mr. Peretto.
Okay,
Back to you, sir.
The video is ended. Just last few words. You saw in the video, AMUT Group next year is going to install 2 recycling facilities in Thailand. For PET bottles will be a facility able to recycle for food grade 32,000 tons a year, and also post-consumer HDPE bottles for 50,000 tons a year. So, I mean, Thailand from next year will have a big step in recycling of post-consumer bottles. Thank you.
Thank you, Mr. Peretto. A big round of applause for Mr. Andrea Peretto, the sales manager in engineering at AMUT Group, Italy. Thank you, sir. All right. So we have our last speaker for this session, the area sales manager for Asia, EREMA Plastic Recycling Systems from Austria, Mr. Fritz Wimmer. We'll bring Mr. Wimmer up on the screen. Hello, Mr. Wimmer.
Good evening. I can hear you well. Hope you can hear me also. I share the screen with you.
Okay. We'll wait for you to set up all the screens, and then a gentle reminder, you have 8 minutes to present. I will give you another reminder when you have 1 minute remaining. Okay, sir?
Okay.
Okay, tell me when you're ready. Let's see the screen. Okay, we share the screen. Your slide is up.
Yes, wonderful. I'm ready.
You're ready? Okay, we are ready. 8 minutes. Your time starts now.
Okay. Good afternoon. EREMA is a plastic recycling machine producer, has gained a lot of experience over all the years of our activity in all 4 corners of the world. So we know very well about the local specialties as well as in various applications. Along with that, we started to produce or develop a series of various machine systems depending what has to be recycled under which conditions. This means we are very well prepared for the today's and tomorrow's challenge, the plastic waste, the post-consumer plastic waste. And from that, we developed our mission. Another life for plastics because we care. And in order to do that efficiently, it is not only EREMA as an extruder manufacturer itself, we are a group of companies taking distinctive care of the specifics like filtration, pelletizing, and so on. With this huge experience and background, it is now already possible to turn dirty post-consumer plastic waste into such high-grade repelletized material that it is possible to use it for a high-end reuse. So no second grade products, but products of same grade or even higher grade. The challenge of post-consumer recycling is not only a challenge for the recycling extrusion maker. No, this is a whole chain of companies. We partner with many companies in the plastic processing machinery, but we partner also with organizations, NGOs, institutes to encourage the collection and to show new ways of collection, as well the research in plastic, in recycling plastic. And by that way, it is nowadays possible to realize complex plants from the material income to the sorting, washing, and pelletizing, and finally handing over to the next company who is making with their production machines high valuable products. Now I show you in brief 2-3 examples. The first one is this one with our technology Reclaim Pro and Refresher. It was possible for the first time to make bottles, shampoo bottles, 100% out from the yellow bag. So from the mixed yellow bag where you have all the plastics together sorted out and recycled in such a way that this is deodorized so that the material has no distinct recycling odor. And it can be used in 100% for a product which is close to the human body, to the human use, and which derives mostly from bottles again. And with the next higher step even, that we can make the material even food grade. So from incoming dirty food bottles, ketchup, milk, juices, we can recycle it in such a way that the end product is not only deodorized, but it is also good for food. So with a monolayer bottle, you can fill again milk or juice in. And this is really closing the loop, bottle to bottle, the highest step of recycling. And we are very proud as EREMA that this was possible for the first time. And I'm even more proud to say that such technology is coming also to Thailand, our friends at PTT, for example. This slide I like most because this shows the way to the future and to the challenge for us as machine producers as well as a recycling concern company to take up any challenge, to take up the challenge of even difficult waste, which is laying around, and work it up in such a way that it is really making high-end end products possible, and that the challenge of today is taken up and enables a greener future for our children and grandchildren and the future to come. According to our mission, another life for plastics because we care. EREMA Technology, thank you very much for your attention.
Thank you, Mr. Fritz Wimmer. A big round of applause for Mr. Fritz Wimmer, the area sales manager for Asia, EREMA Plastic Recycling System from Austria. As you can see, the last picture there, Mr. Wimmer said is one of his favorite picture. Yeah, this is nature, right? Nature. We live in harmony with nature, so we got to take care of nature. As you can see from all of our guest speakers in this session, technology is very important. Innovation is very important in helping out the world. But then again, there's other factors that involves in making this world a better place. And then one of them is human beings. It's us. So I would like to take this this session into the discussion panel. We will have about 3 minutes each to answer the questions. I will have 3 questions. Okay, 1 question for 2 of our guest speakers. We will start from Mr. Setha, and the question is, what is the most essential factor that can advance the field of waste management or maximize resource utilization? Okay. This is the question, and Mr. Setha will be the first person to answer this question with 3 minutes. Mr. Setha, if you're ready?
Ready.
Your time starts now.
ครับก็ขอพูดภาษาไทยนะครับจริงๆผมมองอย่างนี้นะครับคือคำตอบสั้นๆแล้วก็พื้นฐานง่ายๆนะครับจริงๆแล้วก็สูงสุดกับสู่สามัญนะครับอย่างแรกก็คือว่าเราจะทำยังไงให้เราสามารถมีกระบวนการคัดแยกนะครับที่ดีก่อนอย่างแรกเลยอันนี้จริงๆแล้วจากเมื่อเช้านี้ท่านรัฐมนตรีก็พูดนะครับว่าจริงๆแล้วสิ่งสำคัญเนี่ยการทำรีไซเคิลเนี่ยจริงๆแล้วคือการที่เราสามารถที่จะ make awareness แล้วก็ให้เยาวชนรุ่นหลังหรือพวกเราก็ตามนะครับสามารถจะแยกพวกวัตถุดิบอันนี้ให้อย่างดีนะครับจริงๆแล้วมันมี case study หลายอันที่เรามองแม้กระทั่ง case study ของที่ญี่ปุ่นเองนะครับเขามีการสอนเด็กแล้วก็ให้สามารถที่จะทำคัดแยกตัววัสดุดิบต่างๆที่เป็นเศษวัสดุของพวกพลาสติกเนี่ยดีมากนะฮะซึ่งอันนี้ก็เป็นส่วนหนึ่งนี่คือเป็นสิ่งสำคัญจริงๆเลยว่าถ้าเราทำอย่างนี้ได้เนี่ยปลายน้ำในการที่จะทำรีไซเคิลหรือกลับเข้ามาก็จะง่ายขึ้นนะครับอันที่2ที่จะขอเรียนก็คือจริงๆแล้วสำคัญคือแน่นอนครับเทคโนโลยีก็เป็นส่วนสำคัญของชีวิตเราในปัจจุบันนะครับจริงๆแล้วผมว่าคงหลีกเลี่ยงไม่ได้ว่าเทคโนโลยีที่ผมกล่าวมาตอนต้นของเราเองในไทยเบฟเองเนี่ยเป็นส่วนช่วยนะครับผลักดันจะทำอย่างไรให้เราสามารถที่จะเรียกว่าช่วยในการคัดแยกหรือว่าทำให้รีไซเคิลได้ดีขึ้นนะครับส่วนหนึ่งที่เราจริงๆแล้วเป็นสิ่งสำคัญณวันนี้ในอนาคตก็จริงก็คือว่าเรากำลัง move ไปถูในประเทศไทยโดยหลักนะครับเป็น aging society นะครับเพราะฉะนั้นเนี่ยแรงงานต่างๆเนี่ยค่อนข้างจะลำบากและหายากแล้วเพราะฉะนั้นเนี่ยการนำ robotic technology หรือว่าเทคโนโลยีเรื่องปัญญาประดิษฐ์ต่างๆมาช่วยก็จะเป็นผลที่สำคัญอันหนึ่งนะครับก็ประมาณ2หัวข้อครับผม
ครับผมขอบคุณครับ Thank you very much Mr. Setha. Same question for Mr. Andrew Lee from ECOCO. What is the most essential factor that can advance the field of waste management or maximize resource utilization? Mr. Lee, you have 3 minutes and your time starts now, sir.
Okay. we think the ECOCO is the most thing is change the people's hospital to recycle. We make everything fun and easy, and everyone can easy to do recycle. They recycle their bottle, recycling their batteries. They not confuse them. They can do everything in their life very naturally. We hope every child in the future will put their bottle in ECOCO machine naturally as their habitat. That's what we in ECOCO want to do. Thank you.
Thank you, Mr. Lee. So making it easy and accessible for the public to start recycling and then building the mindset of the younger generations for the importance of recycling, that will help as a factor. Thank you, Mr. Andrew Lee. Thank you. Next, I would like to bring the next question for Mr. Samir. The question is, what is the biggest challenge in building a closed-loop waste management at the moment? Repeat. What is the biggest challenge in building a closed-loop waste management at the moment? Mr. Samir Kamal, would you like to answer this question with 3 minutes? And your time starts now,
Thank
sir.
you. Thanks. For me, I think the big challenge with the closing loops is the size of the loop. And again, I sort of revert back to my history. 15 years ago, recycling was a global activity where a bottle that was collected in the United States might be recycled in China. And that kind of a global loop is just so inefficient and so impactful that you're hard pressed to truly save resources or recover resources in a net positive fashion. I read a National Geographic article years ago about water dams in water challenged communities, and how they're very often trying to build very large water dams in order to solve the problem for a whole country or a large portion of a country. But that in fact, instead of putting one very huge dam that might cost billions or hundreds of millions of dollars in place in order to be able to provide water and energy to a large community, a whole bunch of really small dams would cost less, would have a significantly lower environmental impact, and would deliver the same or better results in terms of water and energy. And this is a concept that I think we're starting to see in waste management, but really needs to be enabled by technology and really needs to be thought through by communities. I think that when you talk about closing the loop and recovering resources, we should be talking about at the community level as much as possible. And of course, there are some things that require larger scale, but again, as technology improves, as I think we saw with Mr. Rockett, that the kind of our technology they're looking at, I imagine, used to be huge in the past and now is getting smaller and smaller and quite exciting. So that's, I think, for me, the one of the biggest challenges.
Thank you very much, Mr. Kamal. Thank you for your answer. Same question to Mr. Fritz Wimmer. What is the biggest challenge in building a closed-loop waste management at this moment? Mr. Wimmer, if you're ready.
Yep, I'm ready.
You have 3 minutes,
to
sir.
answer this question in brief, I would say we must bring the whole chain together. And I mean the chain starting from making the virgin plastic over the production of making a product out of it to the user, to the brand owner, beverage or whatever, who make a packaging, for example, to the consumer and to the recycler and all the way back. Yeah? Everybody must know or must be adjusted that recycling is necessary and do the best in his section to make recycling possible by the design of the polymer, by the design of the production machine to make a bottle, by the design of the packaging itself, yeah? And of course the design of the recycling. So we must understand each other, yeah? And do the best so that the next one in the chain can use it. And this is why we, for example, we partner with all these companies to make this chain possible and working. And from the little examples which I have shown you, you see something incredible comes out if all of them work together.
So everybody has to work in harmony, hand in hand, to make this happen.
Correct, because we need to understand what do we get as a prepared material, and we need to understand the next step, what does the bottle maker, the bottle blowing machine or the film making machine or whatever need as a quality. And then it will work.
Okay, thank you very much, Mr. Wimmer. Thank you. And my last question for our two remaining speakers. Before leaving this session, is there anything else that you two think that it's important to leave for this symposium, as well as to address the public of the importance of waste management in today's world? I'll start with Mr. Andrea Peretto from AMUT. Mr. Andrea, your microphone is off. Can you please turn your microphone back on, sir? We cannot hear you. I'm sorry.
Yeah, can you hear me now?
Yes, sir. We can hear you now. So just a quick repeat of what I asked. Is there anything else you want to address the public?
Yeah, I want to talk a little bit about the situation in Southeast Asia. Mr. Kamal is an expert of waste management, and he was right before. Till a few years ago, most of the plastic waste was exported in China, and all Southeast Asia countries, they never face or they never think about the issue how to handle the local plastic waste. Now China banned the import of plastic waste. And every country in Southeast Asia is facing the same problem, how to handle the plastic waste. With the technology, now you can do everything. We can, like Mr. Wimmer said, we can use post-consumer bottles to produce bottles again. And that's why we have the bottle-to-bottle technology. We can produce a milk bottle from waste HDPE bottles. So the target now is how to educate the people to recycle the plastic waste and how to organize at community level MRF, material recycling facility, and invest in technology to recycle the plastic waste. I think Thailand with GC, they are one of the first to invest in Southeast Asia. Thank you.
Thank you, Mr. Andrea from AMUT. And same question to you, Mr. Mike Rockett. Do you have any closing remarks with regards to waste management and how we can address the public the importance of the waste management? Any closing remarks, sir?
Sure. Yeah, I mentioned it briefly in my presentation, but I think in addition to the mantra of reduce, reuse, recycle, we should also think of waste as a resource. Reducing, reusing are going to be always the best. And traditional recycling is never going to be replaced. It's frequently going to be more cost efficient than, say, our technology for recycling paper to paper and separated plastics to separated plastics, for example. But even for the rest of that waste, it could be viewed as a resource. It can be used again at an elemental level to produce new products. And that does two things. One, it keeps that waste from going into the environment, into the ocean, into a landfill and other places. And it keeps a molecule or an atom of carbon from being pulled out of the ground to produce those resources that we need. So we're basically using a carbon that's already up here on the earth to produce another product, just at a very simplistic level. That helps climate change because you're not pulling that atom out of the ground. And so I think not just for the public, but also for governmental agencies to treat waste as a resource, to make sure that it's gathered, not disposed in landfills, not thrown in the ocean, but gathered up in a way that it can be sent to either a distributed facility or a centralized facility for further processing.
Is it difficult to actually change the mindset of people to actually look at waste as a resource, Mr. Rockett?
I think based on the energy at the symposium, I think there are a lot of companies that are viewing it as a resource. The question is going to be, what are the economic incentives for individuals and for companies? You know, obviously building big facilities of any sort, of any of the companies here, are expensive. And so the economics have to be correct. For our particular technology, when you get up to a big enough scale, you are producing very valuable products out the back end. And so that waste is a valuable resource. And so I think encouraging its collection and adjusting the economics appropriately will help.
Thank you, Mr. Mike Rockett from InEnTec Inc., United States of America. So that wraps up our panel of discussion for this afternoon and our discussion of waste management, viewing waste as a resource. So thank you all, gentlemen, joining us from all over the world. Thank you very much. A big round of applause for everyone. Thank you. Thank you, sir. Thank you. ขอบคุณครับ 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 Thank you very much. Thank you very much.